Hey everyone, gonna go over systems of equations today. It is something that we've just want to do a review, just make sure we kind of keep it fresh in our memory, so we understand what it is. Um, there may be some geometry we do with it, but otherwise probably not. I just want to make sure that you know how to do it because it is something that you are going to need to use next year, and where some of you might not end up having another um, math class for other 6 months or so. I just want to kind of hit the review so we kind of have it in our memory. And if we do use it, we'll use it. But you're definitely going to need to know it on MCAS, so we'll definitely kind of review it again as MCAS has come in. So I just wanted to kind of put it out there for today. So, systems of equations, what those are a pair of equations that are solved at the same time to find a point that will make both equations true. Um, so as we kind of go through it, you'll see we're going to try to find a point, an xy coordinate that we're able to plug into both equations to get a true statement. There are three methods of solving them. We're going to go over all three today, um, and then we'll just kind of figure out which one's the best to use depending on the situation. The first method is graphing. This is the most infrequently used one. Just because it involves graphing, but you really want to make sure that your graphs are pretty accurate as you're doing this one. The second method is substitution, where that's substituting something into another equation. We'll kind of show you how to do that. And then the last one's elimination, which is the main way to do it, the way I like to solve them more often than not. Okay, so graphing, we're going to solve this system of equation by the graphing. Again, I'm going to do an example. You'll follow up with the next one. So here we're trying to solve the equations 4x minus 7y equals 28, and then x minus y equals 4. Again, there's going to be one set of points that's going to make both of these equations true. So what we're looking for in that instance is the point where our lines cross. All of these systems, as we're doing them, if we're able to get a point where our lines cross on our graph, that's going to be the point that's going to make both equations true. If on the other methods that we were solving with substitution or elimination, if we took the time to actually solve those, to graph those equations, where the lines cross should be the point where what we're finding as we're doing the solving of the equations that way. So the first thing to do to graph these, we talked about yesterday with graphing standard form equations, is to find the x and y intercepts. Remember, I'm not going to show it, but remember that substituting 0 in for the x and the y value, solving for the other variable that we didn't substitute for, and getting the x-intercept. So if we were solving for the x-intercept in the first equation, we're going to plug 0 in for y, which is going to leave us 4x equals 28. We divide by 4, we end up getting x is 7. So I'm going to kind of plot that graph first. The points are going to bounce in as we go. We'll see a point at negative 7. We have another point at negative 4. That satisfies, and those are our intercepts. Then we graph that line. Again, same thing for the second equation, a little bit easier. We see x minus y equals 4, so in one instance x is going to be 4. The other instance y is going to be negative 4. We kind of see where our point, I think, is going to cross. Our lines cross at that point 0, 4, so that actually is our answer for this graph. Does that make sense to everyone? Everybody sees what we're doing there? We're just graphing two lines as straight as possible because we need to have that exact point where they cross. Okay. Hopefully you guys at home have graph paper. If not, it's going to be a little trickier to do. But just try to kind of figure out with this graphing method on this equation what we think the answer is. And when you find the answer, plug it in the Edpuzzle, and again, come back and check what you had. Okay, so we should have the answer now. We've kind of plotted our points again. This is what your graph should look like. And we see that our answer should be that point 4 comma negative 2. Hope everybody got that. Like I say, graphing's not that important to use. There will be a couple of problems on the quiz with it, but it is something that we use the other methods more often than not rather than this one. Okay, so solving using the substitution method. I'm going to go through the steps, and then on the next slide we'll go through a problem showing you what those steps look like. The first step is to solve one of the equations for a variable. You're going to have two equations. What you're going to do is you're going to take one of them and solve it for a variable. We're going to use this more often than not when we can easily solve one of our equations for one of the variables. It's something that sticks out there'll be very little math involved or algebra involved to solve for that variable. Once you have that, then you're going to plug that answer, whatever you found that variable equals, you're going to plug that into the other equation for that variable. So if you've found in your problem that you solve for y and you get y equals some value, some equation, because it's going to be something x minus or plus something, you're going to plug that equation in for wherever you see y. Then you're going to solve that equation, whatever that comes out to be, solve that for, if you would solve the original one for y, solve for x. Once you find that value, you've solved and you've got x equals some number, you're going to plug that value for x back into either of the two equations, either of the three equations you see. Then you're going to solve that for that other variable. And as always, we're going to write our answers in an ordered pair. That is the actual solution for the system of equations, is that point, the coordinate point, the ordered pair that represents where those lines would cross. So here's our example. We're solving 2x plus 3y equals 13 and 2x plus y equals 7. Like I said, to do substitution, we're going to try to do the problem that has the least amount of work involved. So in our example here, sorry about that, we can solve for either x or y. I'm going to solve for the y here because it's going to be in the second equation. I'm going to solve that second equation for y, so it's just really subtracting 2x from both sides. So when I do that, my step one, I end up with y equals negative 2x plus 7. So once I do that, my step 2 and 3, I kind of combine them together. I plug that in for y into that first equation because I solved the other one for y. So now my equation becomes 2x plus 3 times, in parentheses, negative 2x plus 7 equals 13. So now we're into our solving problems, our multi-step problems again. So we're going to solve that for x. We're going to distribute the 3 through the parentheses. We end up with 2x minus 6y, or 2x minus 6x plus 21 equals 13. We're going to combine our like terms. We're going to move the values over to the other side. So we end up with negative 4x equals negative 8. We divide by negative 4 and we end up with x equals 2. So we've solved our first equation for our variable for x. We're going to take that x value now for step 4 and plug it into either of the equations. Again, I picked the second one because it's easier math once I kind of plug the value in and start solving it. So I plug 2 in, I get 2 times 2 plus y equals 7. So I get 4 plus y equals 7. I subtract 4 from both sides, and we end up with y equals 3. So then the last answer, the last part, is just write it as an ordered pair. So my x is 2, my y is 3. The ordered pair is 2, 3. Did that make sense? Did everybody see that? Because you're going to have to do one next on your own. Okay. So like I said, we got this problem. I want you to solve it, get the ordered pair, plug that ordered pair into Edpuzzle, then come back and check your work. Make sure you got the right answer, okay? All right, so everybody's done that. We'll kind of go through here. Here are all our steps. I solved the first equation for x. It was the easiest amount of math. I just added 3y to both sides. I got x equaled 3y. Plug 3y in again wherever I see x. So I end up with 3 times 3y minus 4y equals negative 10. Combine, multiply that through, combine our like terms. We get to 5y equals negative 10. So our y equals negative 2. We plug negative 2 back into either of the equations. I picked the second one again because it's going to be a point once I multiply through. I'm going to have y, x plus something is going to equal 0. Excuse me again, I apologize. So we've done that. We get multiplied through negative 3 times negative 2, we get 6. So x plus 6 equals 0. We subtract 6 from both sides. We get x equals negative 6. So then our point is negative 6, negative 2. Good job if you got that right. If not, we'll kind of go over it again on Wednesday. Because this part is going to be on the quiz. So I want to make sure we really understand what the quiz is, what we're working with, so that we can do these problems as we go through them. Okay, here we go. Next one. here we're solving by what they call elimination, the elimination method. What we're trying to do is we're trying to eliminate a variable as we're solving these problems. So the other one we eliminated, so if we kind of go back and look at substitution, we eliminated the variable by solving for it, substituting in. Here we're actually going to try to eliminate the variable from the equation as we go through to help us get the answer. So your first step in the pair of equations is to identify if there's a variable in the equation that has opposite coefficients. What I mean by that, just like the opposite reciprocal stuff, is the opposite coefficient is if one variable has a coefficient of 3, like 3x, and the other equation is minus 3x or negative 3x, those are opposite coefficients, and we have what we need to do. We can go from there down to step 2 and work through from there. If you can't identify or don't see opposite coefficients, what you need to do is you need to opposite one or both of the equations by some factor that will create opposite coefficients. So you might have two equations that are like 3x plus 2y equals 5, and then 3x minus 6y equals 7. What we're looking at there is we have x's both have a coefficient of 3, so what you do is you just multiply one of the equations by -1, which would flip all the signs in that equation and then make us opposite equations for our example. You'll see as we go through the example on the next page, the next slide, what I'm talking about, what I mean. But what we're doing here is once we've identified the opposite coefficients and we have them, what you do is you're just going to add the equations together. Having the opposite coefficients, if we add -2 and 2 together, we get 0. It eliminates that variable then. So then step 3 is just to solve whatever's left over. We've eliminated, say, x. We have y, some coefficient of y equals some constant. We're just going to solve for the y value. Again, once we find that equation, that solution for that equation, the y or the x we solve for, we're going to plug that variable back into any of the original equations. Don't do the one that you multiplied by the factor. Do one of the original equations to solve for that other variable, and then as always, we're going to write our solution as an ordered pair. So I think I kind of talked through that quickly. We'll kind of go through the steps on this next slide. I'll try to do it a little more slowly so we can see what we're working on. So we have two examples to show you both what I'm talking about on each thing. The first example, we look at our equations. We have 2x minus 4y equals 7, and 6x plus 4y equals 9. I notice right away that I have a positive 4 and a negative 4 in each of the equations. So I do have my opposite coefficients. So my step here is to add the equations together. So when I add the equations together, I'm left with 8x plus 0y. What you would do as you're doing the problems out is just kind of cross out the y's and don't even bring that step down. I just put it in here to show you what we had. So 8x plus 0y equals 16. So now I'm just solving that equation, trying to figure out what x is. So I divide both sides by 8, and I end up with x equals 2. Does that make sense? Does everybody see what we did there? We just eliminated the y. That's what we're trying to do, elimination method. We're eliminating a variable. In this instance, I eliminated the y. Okay, so now we got our value for x. I can plug that into either of those two equations. I pick the first one. So I get 2 times 2 minus 4y equals 7. So 4 minus 4y equals 7. I subtract 4 from both sides. I end up with negative 4y equals 3. So I end up with my y value equals negative 3/4. So it's kind of ugly, but it still works. So my answer for this particular equation is 2 and negative 3/4. If we plug those into those equations for the x and the y, we're going to get whatever side on the left is going to equal 9 or equal 7, depending on how it works. Does that make sense to everyone? I think everybody should understand that and see that it does work. Okay, so the next one's a little trickier because we look at it and we don't have opposite coefficients. Again, we can pick either variable to work with. We can multiply the equations by something to get opposite coefficients on the y, or we can multiply by something to get the opposite coefficients on the x. What I did is I picked the x in my example because it's just one equation that I have to multiply by. I have to multiply the second equation by negative 6. If I do that, I'll have a 6x and a negative 6x. So that's my line there. I multiplied by negative 6, which gives me negative 6x minus 12y equals negative 48. Remember, we're multiplying by the negative, so it's going to flip all the signs in the equation. From there, once I've done that, I just bring my other equation down, and we add the two equations together. The x's go away. The coefficients cancel each other out, so it becomes 0 times x, so they go away. I'm left with negative 15y equals negative 30. Again, what we're going to do here is we're going to divide by negative 15 to solve for the y value. So divide both sides by negative 15. We end up with y equals 2. So again, we have y equals 2. I have our y value. I just plug that into one of the original equations. I pick the second equation. Before I multiplied it by 6, just go with the second equation that we have. You don't need to worry about the one that you multiplied. So I have x plus 2 times 2 equals 8. So I have x plus 4 equals 8. We subtract 4 from both sides. We find out that x equals 4. So our answer as an ordered pair is 4, 2. So again, it doesn't matter which order you solve for the variables in. It just matters of trying to figure out which method is going to be the easiest for you to solve and do the least amount of math, really, is what I look at. I've talked about, like on the quiz, these are huge problems on the quiz. There's probably going to be more of a graphing problem on the quiz because they're easy to do on the online portion that way. Then I'm going to have you do, you'll probably see a big long order of operation or systems of equations problem on the written test because it's just that's where I want to test that. And it's easier for me to assign the different points for the different parts of the test, the question. Okay? So here we got 2 examples for you to work through. I know it's probably going to take you a little while to work through them. That's okay. Take your time, solve for both the x and the y, and plug your answers in the Edpuzzle, and then come back and check your work. The steps will all be there. You'll see them as they kind of pop up. Okay? All right, so here we go with our answers. We'll kind of go through a little bit. I'll put them up this way so the kind of steps come in. You can kind of double check as you're going through. So you should have had x equaled 8 for the first part is what I did. I solved for, obviously looking at that. The y's have the opposite coefficient, so we're going to solve for x first. Should add x equals 8. We'll plug 8 back into one of the equations. I picked the first one, my example. So you should end up with an 8 minus 2, 8 comma negative 2 as your solution to that problem. Does everybody get that one? Okay. So again, we're going to go to the next one now. We're going to double check that. I multiplied the top equation by negative 2. It was the easiest way for me to do it. So we got our solution there, multiplied by negative 1. We multiplied by negative 1. We got our answer there. Brought down the other equation, added them together. Should have ended up with 4y equals 4. So obviously y equals 1. We plug that back into either of the equations. Again, I picked the first one. So we end up with 2x minus 8 equals 16. Added 8 to both sides, 2x equaled 24, so my x value should be 12. So our answer there is going to be 12, 1. If you wanted to take the time and plug those in and see how it would work, you can plug both of those points into each of the equations. They should satisfy them both to be true, and everything would work out, and we would have the correct thing. Okay, so tomorrow is the half a day. We'll do a Zoom call. It's the link that we used last Wednesday. It'll be the same link going forward. We'll kind of go over, I'll ask any questions that we had on this to kind of go over that. And then we'll kind of talk about what the quiz is going to look like on Friday, just so you can kind of see what you're going to have to be doing. But it's going to be on everything we've kind of covered from last Thursday to today. So kind of go over your notes you had from class last week and then the stuff you did yesterday in the video. You can always go back and watch the videos. The videos will stay out there for the whole year. You can kind of go back and look and see what did I do, what do I need to look at, how do I review my material to make sure that you do understand it. Like I said, they're always going to be there for you to review. So I will see everybody and talk to everybody tomorrow. Have a good day.